Rishika and I am studying in 9th standard D section. So today I have an interesting topic, that is maths, the invisible hero. Yeah guys, maths is all around us, not only in just paper, it is everywhere around us. Come on, let's see how it is applicable in everyday life. Okay, before proceeding, I'll just ask you something. Will you believe it that the maps which we are using, the world maps, are fake? Yeah guys, it is fake. Why? Because in real life and in scientifically, China is 4.4 times larger than Greenland. But in maps, when we see Greenland and China, both are almost in equal size. Why is it so? Come on, let's understand this by a remarkable theorem. Yeah guys, this theorem was given by the mathematician called Gauss. He is a German mathematician and he is also called as the Prince of Mathematics. Okay, what is remarkable theorem? To observe that, we will see an example. So this is a flat surface. Now, to find the curvature of this surface, I have to consider it both vertically and horizontally. Vertically, it is 0 curvature, and horizontally, 0 curvature. So 0 into 0, 0 curvature. So this total flat surface curvature is 0. Now, you may ask, when I roll this paper into the cylindrical shape, then the curvature changes, right? Yeah, it changes only in horizontally. But what about vertically? It still stays 0. So that positive into 0, again you will get 0 curvature. That's why the remarkable theorem states that when we bend an object, its curvature will not change. When it is as it is 0 curvature. Even when I bend it, it is also 0 curvature. That's what remarkable theorem states. Okay, we'll see how it is applicable in maps. Now, when you take a globe, an actual sphere, you can see that China is larger than Greenland. But why it is equal in size, or sometimes Greenland is larger than China in maps alone? Because we can't turn a sphere or curved surface directly into flat surface. Another one example will be when I take a gift wrapper and a ball, when I try to cover it, I can't wrap it properly because it has some mismatches. Because a flat surface cannot be a curved surface, a curved surface cannot be this flat surface. That is the reason behind this. That's why when they are converting the sphere into the flat surface, they used to enlarge the sizes of top and bottom area so that Greenland is enlarged compared to China. That's why in maps we have both the sizes to be equal, or else sometimes in some maps Greenland is to be larger than China. Okay, now we'll see some other examples for curved figures, which is in our day-to-day life. When you take a pizza for eating, always the pizza would fall due to some cheesiness. But you will use a small trick. You will bend the cheese, bend the pizza, and you will eat, so that it would be proper for you to eat. Here, a small curve shape is formed. This curve shape is called as parabola. And what is parabola? We'll just see. Parabola is a type of conic section. We have 4 types of conic sections. First is circle, next one ellipse, next parabola, then hyperbola. We have lots of examples for parabola and hyperbola, such as cardboard. Inside cardboard, we have lots of parabola figures and sheets. Guitar, it is an example for hyperbola. Then shutter. Even in studio rooms, we have a light stand. This also comes under parabola. And concave lens, which is used in telescopes and binoculars, is also comes under hyperbola, as it is bent inwards both the sides. Then sand clock, hyperbola. Then we use more hyperbola and parabola in construction purpose, because these curved figures will be leading to a strongest figure, so that it would be a great basement. We use this in Eiffel Tower. Then Dallas Airport. Here we use a parabola shape as a roof. Then in San Francisco we have Bay Bridge. Then Bixby Creek Bridge. Then even roller coasters. And in Chennai we have Napier Bridge, which is also made by parabolic arc. So here this parabolic arc is not only used as a design, it is a major concept which is used for keeping the bridge very strong. Next we have the Coke Port. curved figures because to make it stronger than the usual. Even if any natural disasters get affected in that area, with these structures we can avoid some more damages. But there will be damages, we can avoid more damages. So by this I conclude that maths is the invisible hero. It stays everywhere and every moment, single thing it stays, but we don't know. It is just this topic is just a part in mathematics. Still we have lots of theorems and lots of number theories. We will not have enough time to learn all those things, but still maths is everywhere and it stays as an invisible hero. Thank you.
Good afternoon to everyone. Myself, V. Logaroshni. Myself, T. Jayapriya. We are from grade 9G. Today, we are here to explain our topic on the concept of parabola. Generally, what is a parabola? A parabola is actually a U-shaped figure which has all the points equidistant from a point called focus and a line called directrix. As you can see the figure, here this line means the directrix and this point on the parabola is said to be a focus. And in simple words, we can say a parabola as a line which is equidistant from a point and a line. And you may have a doubt that whether all the shapes comes under parabola. There are many shapes such as ellipse, circles and the figures drawn using free run. Do they all come under parabola? Absolutely no, because parabola follows some unique properties. Some of the properties are, first and foremost thing is the reflective property of the parabola, which plays an important role in many other applications in our real life. And the second property is the directrix property, which means that the point on the parabola is always equidistant to a point to the focus and the line to the directrix. To depict our model, we are having three applications. The first one is the satellite model, the second one is the passing parabola, and the third one is the parabolic bridge. So now I will be explaining about the passing parabola. A straight bar passing parabola is a model used to demonstrate how a straight bar can pass through a parabola. It is typically used in physics to illustrate how a straight bar is manipulated to pass through a parabola. It is used to show how the shape of parabola is obtained by manipulating the orientation of the bar. It is used to show the curvature, how the curvature of the parabola is changed by the orientation of the bar. It is being used in science parks and educational institutions. The mathematical concept behind the parabola are the quadratic equation. The parabola is the graph of x equal to ay square plus by plus c. And the parabola is symmetrical about its axis and it is equally balanced on the both sides. The turning point where the parabola changes the direction is called the vertex. So now you can see that this bar is little lengther than this curve. So it goes inside and comes due to the curvature of the parabola. So in this graph, the line passing through this curve is called the tangent. And the next application on the parabola is the parabolic satellite model. So in this application, it is a simple model to explain the principle of light using a parabolic shaped surface. Here the satellite dish is used as the parabolic surface and many other places use as the dish in the parabolic surface only. By this model, you will understand answer for the question that why these dishes are the shape of a parabola. And here we are having our satellite with the light, which is inserted with a light source and having a power supply. When the light source is switched on, the rays emitted by the power supply get hits in the reflective surface and get reflected back according to the laws of reflection. Here you maybe have the doubt, why does laws of reflection comes here? It is a concept involved in physics, but here you need to understand the point that here it follows a geometric rule that always angle of incidence is equal to the angle of reflection. And by this model, we can depict many other real life examples in our world. Such examples are headlights, solar concentrators, flashlights, torches, etc.
Good morning to one and all present here. I am S.T. Kadran from 7th Standard Head Section. My topic is probability. So, what is probability? There are many instances in our life where the results cannot be predicted beforehand with absolute certainty. Like, will it rain tomorrow or will India win the match? So, we cannot be absolutely sure to predict some results, but we can still say some results with mild probability. So, here I have probability line which contains 0, even chance and certain. So I will explain these chances with the help of these marbles. So I have 5 sets of marbles. I want to pick a blue one. So in this set there are 4 blue marbles. So I can be sure that I will pick a blue marble. And in this set there are only 4 white marbles. So I am sure that I cannot even pick a blue marble from this. And from this there are 2 white marbles and 2 blue marbles. So my chance would be half, that is 50-50 while taking a blue marble. And in this 3 out of 4 is blue, and in this only 1 out of 4 is blue. So my chances are greater in this than this. So my chances will be impossible in this, less likely, even chance, more likely, and absolute certain in this. So these variations are given a numerical value in branch of mathematics called probability. So probability value always lies between 0 and 1. 0 being impossible that our likelihood of event will never occur, and 1 being absolute certain that our likelihood of event will occur. And even chance, which lies between somewhere between 0 and certain, with which we can say which event may occur or may not occur. We cannot be sure while it's an even chance, like tossing a coin and rolling a die. So how to calculate probability value? Probability value is the ratio of number of all possible outcomes to the total number of outcomes. So the classical examples are rolling a die and tossing a fair coin. So tossing before going into that, what is a fair coin? A fair coin is that it has equal amount of weight between these two spaces, like not weight on one side, heads or tails. So while tossing a coin, we can say that it may be heads or tails. So calculating the probability value, there are 2 total possible outcomes for heads and tails, and we want heads. So while tossing a coin, we can say that our probability value 1/2, that is probability for getting a heads. This goes same for tail too. And rolling a die. So this tossing a fair coin, this we should also roll a fair die, like not weight on one side much. So we can get 6 possible outcomes: 1, 2, 3, 4, 5 and 6. So we may get any outcome. For getting outcome 4, there is 1/6 chances. But for getting number divisible by 2, there are only 3 chances: 2, 4 and 6. So our probability value will be 3/6 or 1/2. Getting number divisible by 3 has very less chance, because it is 3. It is only 3 and 6. So our probability value will be 2/6 or 1/3 accordingly. So in general, we can say that probability cannot tell what exactly will happen, but help us to know our chances. Thank you.
Pleasant noon. I am Pranav Subramanian of 7th year.
Myself, Bhuvanesh of grade 7.
My project is solar tracking system. Before we go into the topic, we can learn about solar panel. A solar panel is a device that converts sunlight into electrical energy. It is made up of tiny solar cells, which is responsible for this. You might have seen fixed solar panels in agricultural fields, schools, homes and industries.
The biggest disadvantage in a fixed solar panel is that it cannot follow the sun. So it gets full sunlight for only a short period of time. To show this, I am using a 5-volt solar panel and a multimeter. When I place the torchlight towards the solar panel, the voltage increases and comes near to the 3 volt. And when I slowly move the torchlight away from the solar panel, the voltage immediately drops. This shows a fixed solar panel loses a lot of energy just because it is not facing the sun at a correct angle. This reduces it lowers its efficiency, and to solve this problem, we have got a solar tracking system.
A solar tracker automatically adjusts the position of the solar panel according to the sun. In the system, we have used 2 LDR sensors, light dependent resistors, as a light detectors. When one LDR gets more light than the other LDR, it sends a signal to the motor driver. The motor driver used in this project is L2990N. This motor driver gets signals from the 2 LDRs and controls a BO motor. When LDR1 gets more light than LDR2, the panel moves towards that side. When LDR2 gets more light than LDR1, the panel
mathematician Pythagoras. It demonstrates in right angle triangle. The square of the hypotenuse is equal to the sum of the square of the other two sides. The numbers such as 3, 4, 5 can represent as Pythagoras triples. This theorem is applicable in construction, navigation and computer graphics. This is simple and practical in maths and it is used in more constructions. Now I am going to show a working model. Here it become right angle triangle. Here the formula of the theorem is a square plus b square equal to c square. Here c stands for hypotenuse, b stands for base and a stands for perpendicular. Thank you.